Good day. In this video, I will specifically look at the effects of graphs as the variables of A, B, and C is changed, and I will show this graphically in a motion picture. We will look at the following functions. The function of x is equal to x, or better known as y is equal to x. We will look at the function ax plus q, where I'm going to change this to the value of a and this to a c value and this to a d value. We will look at f of x is equal to ax squared plus bx plus c. This is the quadratic one. The ax plus q is the linear one. And then we're going to look at the cubic one as well. Firstly, we will look at when I say y is equal to 3, then this will be the line at that point across there. In this instance, we are looking at the linear function y is equal to ax, and as my gradient changes and my information changes, I can see that this graph takes this turn, and I'm going to add now. That is just y is equal to ax plus q. So I'm going to add the q value, and what will happen as the q value changes, the graph now shifts up or down according to the information of my d value. D tells me where the graph will cut my y-axis, or also known as my y-intercept. For this one, I'm going to look at my quadratic function, and that is when I say y is equal to ax squared plus bx plus c. When my gradient is positive, my function will face upwards, will be a minimum value, but when I have a negative a, then I have an inversion of that, and I will have a maximum value. There once again, a minimum value. When a is positive, we change this as we see c changes. I can see that the graph now also moves into a direction. Now I will add the motion of d. As d also starts to move, it tells me where my graph will cut my y-axis. For the last one, I'm going to look at the cubic function, how the cubic function is affected when my a value is increased or decreased. Now I'm working with ax to the power of 3 plus bx plus squared plus cx plus d. So there's my a value. I'm going to add the d value, and the d value is merely where it will cut the y-axis. So the shape and the form of the function will be determined by that information. Then as I start moving my b value, notice what happens to the graph now. It starts to show two turning points or stationary points, which we call then the minimum or maximum value. And when I add c to this, I can notice how this graph then moves and how the turning points or stationary points are affected, as well as the y-intercept as the graph moves along between 5 and minus 5. Right, for our next video, we will look at the exponential graph, where we work with a, b, x plus p as an exponent and plus q. And then we will work with the hyperbola, which is a over x plus p plus q. So let's first start with the exponential graph. Right, we look at the exponential graph, and here we work with variables a, b, p, and q. So we first start off with b, which is your number to a power, and see how this graph is affected. if A is 1 at least. A must be at least 1. Let's make A 1. Right, we can see there with the negative values of B, it does not have any effect, but then when it becomes positive, I can see there this graph taking its course. Then I'm going to add P. P means there's first do Q, because Q is a positive or negative shift up or down. So let's look at that first. Graph shifts and flips over between the quadrants 1, 2, and as it shifts down. So now we will add the movement of P, and you will notice that this graph becomes steeper quicker, or it becomes more relaxed as it goes along. We follow through. Moment it reaches positive, it's going to shift this one, start the A value, and see what happens with the A value. As long as A is there, and look at what happens to the graph the moment the A value and the B value both are negative. There's still no graph until you see the graph working with fractions between 1 and 0, the effect of the graph. Right, so we look at the hyperbola now. If A is negative, I see that the graph is in the second and in the fourth quadrant. If A is positive, it's in the first and the third quadrant. We're going to add the motion of Q, because at present the asymptotes is the y-axis and the x-axis. But as my Q increases, the graph moves up. As my Q decreases, the graph moves down. So we're going to add the motion of P to this, and I will see if P is negative, my graph moves to the right. If P moves in a positive direction, then my graph moves to the left. Trust and hope that everyone could see this movement, the inverse direction from the sign. It's most important thing to notice with this particular graph. I want to thank you for watching this video. If you liked it, tell your friends. If you loved it, tell everyone. I will see you in the next one. Functions should now be child's play. Trust you enjoyed it and will use this knowledge to your advantage.